For today's lab, we're going to react solutions of silver nitrates and potassium chromates. We are going to determine the limiting reactant using the continuous variation method. And to start us all off, the first thing we need to do is make our solutions. When we make solutions, we want to use what's called a volumetric flask. This is a flask that has a single marking. It's finely calibrated. And so we calculate out the amount of solute that needs to go into the flask, and then we dilute it with deionized water until it gets to the mark. Once it gets to the mark, we know that the total volume is exactly 100 milliliters, according to this flask. They make flasks in all sorts of different sizes, but the ones we need today are 100 milliliters. So we're going to make our solutions of silver nitrate and of potassium chromate this way. So I've added my solute to the flask, and you can kind of see it in the bottom. We want to get it fully dissolved. I only fill up the flask about halfway or so. That gives me room to swirl the solution. Still a couple chunks in there at the bottom. I don't know if you can see that. So we swirl till it's dissolved. We're almost there. And then we will add more deionized water. And remember that there's the one line that we have to be mindful of. So I'm going to add the deionized water to the flask. If we get closer, and if I don't feel confident with the water bottle, I may switch to a dropper. Because I really don't want to pass the line, because when you've surpassed the volume, then the concentration is no longer what you calculated it to be. Although this is a very fine tip water bottle, I think we'll be okay with this one. Whenever we read any kind of solution in any kind of glassware, you read to the bottom of the curve, the bottom of the meniscus. I'm going to stop here and invert this a couple more times with a rubber stopper, because I see some droplets along the neck here. So now I have my solution made. This is silver nitrate. I'm going to repeat the procedure to make the potassium chromate solution. Because the lab requires small measurements of solutions, we reference our data table here. You can see that we're going to need half a milliliter, 1 milliliter, 1.5 milliliters, and so on. These values are too small to accurately measure with a graduated cylinder. So instead, we use a pipette. This is a pipette. Essentially, it looks like a long, skinny test tube, but it's finely graduated. So it's marked to the tenths of milliliters. And the way that we use it is we attach it to a pipette pump. So to assemble it, you unscrew the adjust here, and you kind of twist the glass end in, and then you've got to tighten. You don't want to over tighten it because you could break the glass, but basically once you get a nice fit, then you know you've adjusted it. So to draw up the liquid, there's a thumb wheel right here. And so you dip the end, you dip the tip in the solution, and you draw the thumb wheel up, and you just gather what you need based on the measurements. We're going to dispense the solutions of potassium chromate into all the test tubes first, and then we'll do the silver nitrate. So now that we've mixed our test tubes, we're going to go ahead and place them in the centrifuge. And it's important to know that when you're using a centrifuge, the weight has to be balanced so that when it starts spinning really fast, you don't have any wobbling. And I have 6 slots, so I'm putting my first 6 test tubes in. And usually you have to plug these things in. Just use your pinky to kind of help pull it out. As you can see, the solid has been compressed towards the bottom. And we go in order. We'll just pull them out. And we'll do the last 4 tubes. So now that we're done spinning the tubes, we want to judge the amount of precipitate that formed. Now, that's going to be kind of difficult here because of the nature of the slant of the solid, and it's kind of going by, we're eyeballing it here. But good thing that that's not going to be the only determiner for which tube is the right mix. So just at a cursory glance here, well, this is the extreme. We'll call this a 1. Call tube 2 more than 1, so we'll call that a 2. Tube 3 looks very similar. It's gonna, we'll call it a 3. Tube 4 has more breadth than tube 3. We're going to call that a 4. Tube 5 looks to have just about as much as tube 4, so we're going to call that a 4 as well. Tube 6 is definitely less. We're going back down to 3. Tube 7 seems to have just as much as tube 6, so we're going to call that a 3 as well. Tube 8, that's definitely less. We'll go back down to 2. Tube 9, there's not very much at all. We'll call that a 1. And tube 10, call that a 1 as well. So those are the numbers that we would record in the data table for the amount of precipitate. And the next row in that table is the color of the supernatant. Now the supernatant is the liquid above the settled solid. So it's the color of the liquid. So as you can see, in tubes 1 through 4, the color is clear. And from 5 all the way through 10, the liquid is yellow. So that's what you would mark in that row. And the last row is the precipitate test of sodium chloride. So this sodium chloride test is when we take the clear supernatant, because in the supernatant, we suspect there might be excess silver nitrate. We know that it doesn't have excess potassium chromate because potassium chromate has the characteristic yellow color. So in the first 4 tubes, all we're going to do is draw a small sample and we're going to add a drop of sodium chloride. And if it turns cloudy, that's the color of silver chloride precipitate. So that is evidence that there's excess silver ion. So if we do that for each of the tubes that has the excess silver, or what we suspect to be excess silver, that will verify. That's tube 2, turned cloudy as well. Tube 3. Cloudy, definitely. And tube 4. And we got some cloudiness there as well. Okay, so it appears then we have excess silver in tubes 1 through 4, and we have excess chromate in tubes 5 through 10. So for your analysis, you need to calculate the mass of both salts needed to make the initial solutions, and this was from the ASA, so by now you've already done this. You need to calculate the initial molarity of the solutions that you made in the 100 milliliter volumetric flasks. You need to calculate the theoretical yield of 3 test tubes. The perfect mixture tube, or the one that you think was the perfect mix tube, and the tube before it, and the tube after. So you need to do limiting reactant calculations for 3 test tubes. You need to state your observations, and then discuss whether your observations match your theoretical calculations. Discuss what error likely caused you to maybe guess the wrong tube, and what kind of improvements that are necessary.